All right, chapter 5, we're going to start talking about the different exponent rules, which we're going to use a ton when we start talking about polynomials, multiplying, dividing, all of that stuff. And then we'll see these again pretty much anytime you work with polynomials, and then also a ton in chapter 6 when we look at factoring. So let's just kind of take a look again at what exponents are, kind of why we use them. Exponents are shorthand for repeated multiplication. So mathematicians just kind of came up with these. They're like shortcuts. They don't want to have to write out everything. So using exponents helps us take something like 5 times 5 times 5 and kind of reduce this down into 5 cubed. And so knowing the terminology here, so the base is the 5 and the 3 is the exponent. This is really important so that we're able to identify whether two terms have the same base, because that's going to help us figure out whether or not we can combine them together. And so just remember, if we have, call that a first example, if we have something like -3 in parentheses squared, the base in this one is -3, but if we have -3 squared without the parentheses, this means that we're squaring just the 3 and then making that negative. So in this one, the base is just 3, not -3. So we'll take a look at this again with the negatives, but we have to be really careful with whether or not the negative is included with the base. All right, so in these first examples here, we're just going to go ahead and identify the base and exponent. I just wrote exponents, meant to write examples. Identify the base and exponent. And then we're also going to evaluate these. Now, evaluate just means simplify down, get it into a nice single number without an exponent. So number 1, you got 2 to the 5th. And so the base here, we'll just call it B. I'll write it out for this first one. The base for this one is just going to be this number that we're raising to the 5th power, so 2. And the exponent is 5. And so if we take 2 to the 5th, we're going to take 2 times 2 times 2 times 2 times 2. And so if we go ahead and multiply 2 times itself 5 times, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So remember, you're always multiplying whatever you get from the previous multiplication by another 2. Make sure you're not just doing 2 times 5 and getting 10. All right, number 2, -2 to the 4th, no parentheses. All right, so the base for this one, since there's no parentheses around this 2, you want to think of this like -1 times 2 to the 4th. Think about it like when you have an x and you have a -1x, but you don't write the -1 in the front, you just write a negative. Same kind of idea here. Instead of writing -1 times 2, we're just putting -2 to the 4th. So the important thing here, if you remember back to order of operations, we do exponents before we multiply. So the base for this exponent is just the 2. The exponent is still that 4. And so when we evaluate this, we're going to leave that negative in front, and then we're going to do 2 times 2 times 2 times 2. And so 2 times 2 is 4, times 2 is 8, times 2 is 16. So these, I'm going to multiply the numbers together first. So this gives us 16, and then we'll just make it negative. So negative 16. And so just to see this the other way, for number 3, we're given negative 2 in parentheses to the 4th. So the base for this one, the thing that we're raising to the 4th power, is the entire negative 2. And our exponent is still 4. And so if we evaluate this one, since we're raising negative 2 to the 4th power, we're taking negative 2 and multiplying it by itself 4 times. So if you can see, there's kind of that difference between the negative appearing every single time, or if the negative just stays out in front. So multiplying this one together, negative 2 times negative 2 is 4. And then I'll do negative 2 times negative 2 is 4. So remember, you can kind of group them, or you can just continuously multiply. And then 4 times 4 is 16. So see how the difference between these two, one is negative 16, one is positive 16. When you have an even exponent like we do here, whether the negative is attached or not to the base, it's going to change it from a negative to a positive answer. If we were cubing, it actually wouldn't make a difference. But be really careful with negatives, because it can be the difference between a positive and negative and right and wrong answer. And this with W slash, just kind of abbreviating here. All right. So let's go ahead and take a look at our first rule here, our first exponent rule. So this one, let's go ahead and take a look at, first of all, kind of why it works. So let's say we wanted to multiply 2 to the 4th times 2 cubed. So what we're going to do here to kind of figure out the rule, we're not going to do this every single time. I'm going to write these both out. So 2 to the 4th is 2 times 2 times 2 times 2. Times 2 cubed is 2 times 2 times 2. And so if we go ahead and look how many 2's we have here, we're multiplying 2 by itself 7 times altogether. So another way of thinking about this is 2 to the 7th. So if you take a look at what we started with and what we ended up with, what do we have to do with our exponents to get from this starting expression to our ending expression? Well, we have to add our exponents. And so this is the case anytime we're multiplying two terms together, they have to have the same base. If they have the same base, so these are both 2's, and they have to be the same sign, so we can't have a 2 and a negative 2, we can go ahead and just add the exponents when we're multiplying. So this is called the product rule, because our product, we're multiplying these together. The product rule, and instead of kind of formally writing out a long definition here, I'm just going to write out our rule that we found up here. So this just says we have two terms, say a to the m times a to the n. If we have the same base and we're multiplying them together, all we have to do is add the exponents. So a to the m plus n, and you keep the same base. So add the exponents, keep the base. And so let's go ahead and look at some examples. This is going to make these problems a lot faster. We're not going to write them all out like we did up here. We're just going to use our exponent rule. And we're told to simplify. So number 1 here, we're given 8 squared times 8 to the 5th. And so if we have the same base, we're multiplying. we want to figure out how many 8s we're multiplying all together. Well, we have 2 here and 5 here, so we have 8 to the 7th. And if you forget your rules, it's really helpful to actually go back to what we did up here, and it'll help you figure out, do I have to add the exponents? Do I multiply them? Because we're going to see some other rules here where you're going to multiply your exponents and subtract them. So you're going to want to know how to kind of break it down like this in case you forget the rules. But we're going to leave it just like this. I'm not going to actually multiply this out because they get really big really fast. And so that's one thing to keep in mind. If it's a smaller number, like 5 squared or something like that, you do want to multiply it out. Normally they'll tell you if the exponent's bigger than 4, don't multiply it out. So just pay attention to what it tells you to do on My Math Lab. Okay, number 2, -7 in parentheses to the 5th times -7 in parentheses to the 3rd. So now with this one, there isn't actually multiplication written in between. We could put it there, but we don't have to because they're written right next to each other. It's implied that we're multiplying. And so we have the same base. We have a -7 on each one. And then we are just going to keep that base. So keep the -7 in parentheses, add the exponent. So 5 plus 3 gives us 8. All right, number 3, z to the 5th, z to the 6th. And so with this one, I'm crossing my z's so they don't look like 2's. We have 3 different terms. Well, we have 3 different variables being multiplied. They're all the same base though. We have z's for each. So we need to add all of their exponents together. Just be careful on this one. Just like when you have like x plus x, there's imaginary 1s in front of these that we don't usually write. Same thing with our exponents. If we have just a z, this is technically z to the 1st. So if we add these, 6 and 5 is 11, plus 1 is 12. So z to the 12th. Just be careful on those. If you don't see the exponent, you can always write it in so you don't forget it's there. All right, number 4. These ones are kind of the special cases of this section. So this one we're given 4 squared times 3 to the 5th. So take a look at that one for a second. And kind of think about why we can't combine these. So I'm going to say cannot simplify. And the reason is because even though we're multiplying 2 terms with exponents, we have a base of 4 and a base of 3. So since they have different bases, we can't combine them together. And that's always going to be the case with all of our rules. If the bases aren't the same and you can't make them the same, and we'll talk about how to do that later, we can't combine them. And our last one here, this one's another special case. So 6 to the 4th plus 6 squared. And I do want to add one thing in to the answer for number 4. Cannot simplify using product rule. You can technically still simplify it. You could multiply 4, you could square the 4, raise 3 to the 5th, and then multiply those together. We've done stuff like that before, but you can't explicitly use this product rule to simplify. And so that's what we're doing for these. So same thing with this one. We could technically simplify number 5. We could raise 6 to the 4th, 6 to the 2nd power, and then add them together. But we're not just simplifying here, we're simplifying using the product rule. So for this one, we cannot simplify using the product rule. And so this is because it's not a product. We have 6 to the 4th plus 6 squared. All right, so that's our product rule. Let's go ahead and try a couple of those that are just a little bit harder, and then we'll take a look at our next rule. So number 6 here, we're given 5m squared times 2m to the 6th. All right, so for these ones, you want to think about what your base is and what we can combine. So in these ones, because there are no parentheses around the 5 and the m, the only thing that's being squared here is the m. Same thing on the second one. The only thing being raised to the 6th power is the m. So we can go ahead and combine those. So m squared times m to the 6th is m to the 8th. So we add our exponents. And we can think of this kind of like multiplying your like terms together. So we can multiply those m's and now multiply 5 times 2, which gives us 10. So just like when you're combining like terms, you're adding and subtracting. This is a little different because we're working with exponents, but I still like to think of it as like parts. So you can multiply your coefficients, you can combine your variables, but only the ones that are exactly the same. All right, number 7, negative 7p to the 5th times 3p to the 8th. So again, I'm going to multiply the like parts together. So negative 7 and negative 3 give us negative 21. And p to the 5th times p to the 8th, we add the exponents and we get p to the 13th. Okay, let's take a look at the next rule, and we'll do kind of like what we did last time. We'll look at example to see why we're doing what we're doing, and then we'll go ahead and figure out the rule from there. So let's go ahead and do 2 cubed in parentheses to the 2nd power, or 2 cubed squared. So let's think about what we're doing here. So when we square something, that means we're multiplying it by itself. So I'm going to take 2 cubed and multiply it by itself. And then we want to go ahead and write both of these out, kind of like what we did last time. So 2 cubed is 2 times 2 times 2. 2 cubed again is 2 times 2 times 2. And so if we go ahead and look at how many 2's we have here altogether, we have 6 of them. So I can write this as 2 to the 6th. So let's take a look at what we started with and what we ended with. We started with 2 cubed squared, ended with 2 to the 6th. So what did we do with our exponents here to get from this 3 and the 2 to the 6th? We had to multiply them. So another reason why it's good to be able to figure out this way, because our previous rule, we had to, oh, let me go turn that off. Okay, so our previous rule, we were adding the exponents together, but we were multiplying the terms. In this one, we are raising an exponent to another exponent, and so we multiply the exponents. So trying to remember which rule or in which circumstance you do which rule can be a lot to remember. One way I like to remember this one is the 3 and the 2, the exponents here are separated by a parenthesis, and we usually use parentheses to show multiplication. So since they're separated by a parenthesis, we want to multiply them together. So that's just one way of remembering it. But just getting in a bunch of practice with these is going to be the most helpful thing you can do to kind of get down these rules. All right, so this is our first power rule. And I believe, I'm not 100% sure, but I believe the book calls this power rule A. I've learned them by different names before. And then your book kind of uses A, B, and C for these, which I don't find as helpful because it's not as descriptive. Just know that there's 3 different power rules that we're going to be talking about. So this first power rule here, we're going to have some term a to the m, raise that to the n power. And so we take our exponents here and we multiply, so a to the m times n. So we multiply the exponents. And see how there's only one base here. So you don't have to worry about having the same base because there's only one base involved here. That's one nice thing about these is that you can't really mess up in that aspect. You still need to be able to identify when to use this rule though. So let's look at some examples before we check out the next power rule. Again, we want to simplify. So number 1, we're given 5 cubed to the 4th power. So with this one, again, we want to multiply our exponents because we only have one base here. So we get 5 to the 12. And 12 is a big exponent, especially put on a 5, so we're not going to multiply that one out because the number would get really big really fast. Number 2, 6 squared to the 5th. Again, one base, we have an exponent raised to an exponent, so we multiply. So we get 6 to the 10th. And one last one here, a to the 6th. Oops. To the 5th. Same thing if we have exponents, or sorry, if we have variables, we're still going to multiply our exponents, and we get a to the 30th. All right, so let's go ahead and take a look at our next power rule. This one we went through really quickly just because all we're doing is multiplying the exponents. The next power rule kind of builds on this, makes it a little bit trickier. So let's go ahead and take a look at an example again. So this one we're given 4x in parentheses cubed. Okay, so we don't have any exponents to multiply together, and we're not using our product rule. So let's go ahead and try writing this one out. So again, we're taking 4x and we're cubing it. So 4x times 4x times 4x. And then I'm going to kind of do some rearranging here. So if you notice, we have 4 times 4 times 4, which is 4 cubed. And we have x times x times x, which is x cubed. So if we take a look at what we started with and what we ended with, we took this cube that was on the outside and we kind of distributed it into both of those parts of the term. So I like to call this distributing the exponents. Just like distributing when you're simplifying an expression. This is really similar. It's not technically distributing. That's not the kind of technical term for this, so your book might not use it, but I think it's a really good way to kind of remember what to do here. So I'm going to put that distribute in quotations. Okay, so that is our power rule B, I believe. So this one just says if we have a product, so A times B, and we raise that whole thing to the m power, then we're going to kind of distribute that exponent in, and we get A to the m, B to the m. So we're going to distribute the exponents. And let's look at some more examples. And so again, for these, we are told to simplify. So number one, they're going to start to get a little bit more complicated, and we'll start bringing all of the rules together in a second here. Number one, we're given in parentheses 2ab to the fourth power. And so what we're going to do is we're going to distribute this 4 exponent into every single part of the term that's on the inside. So not just the variables, the number in front also, so the coefficient. That's just a really common one to miss distributing the exponent to. So get in the habit of just always, you could even draw in the lines if you want to, show that you're distributing it to every single part of that term. So we have 2 to the 4th, a to the 4th, b to the 4th. And I'm going to go ahead and simplify this a little bit further. These are all being multiplied, but they don't have the same base. So we can't combine these parts, but 2 to the 4th is a nice number. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16, a to the 4th, b to the 4th. So things to keep in mind as you're going through, do they have the same base? If so, you can use the product rule. And if not, see what you can kind of simplify down like we did here. All right, number 2, 5 parentheses mn cubed. So for this one, you want to think back to when you distribute. You only distribute to things inside the parentheses. Same thing here. This cube is going to the n and the m, but it's not going to the 5. That one's just going to stay out in front. And when we distribute, we get rid of the parentheses. So we have m cubed, n cubed, and that 5 is just kind of hanging out in the front. All right, number 3, in parentheses, 3a squared b to the 4th, all raised to the 5th power. So this is where they start to get a little bit more complicated because we have exponents on the inside and this one on the outside. So I like to break these down into multiple steps so you, it's a little bit more difficult to mess up if you break it down like this. If you try to do everything at once, it's going to make it kind of messy and you might forget where you are. So what I'm going to do is I'm going to distribute this 5 exponent into all of those. And then I'm going to write that new expression. And I'm not going to do anything with these exponents here quite yet. So what I'm going to do is I'm going to write it as 3 to the 5th. And then we're taking a squared, raising it to the 5th. So a squared in parentheses to the 5th, and then b to the 4th in parentheses to the 5th. So if you notice the 3a squared and b to the 4th all now have a 5 as an exponent. And now we can go ahead and use some of our other rules. 3 to the 5th isn't too bad to multiply out. If you do 3 times itself 5 times, you get 243. And then think about what rule you use here. So exponent raised to an exponent. And remember the exponents are separated by parentheses. So we're going to multiply. So a to the 10th, b to the 20th. So we combined our first 2 power rules here. We have the one where we multiply and we distributed. Let's try one more of these. Negative 5m squared in parentheses cubed. All right, so this is another one you have to be careful with. We have this 3 on the outside, so we want to distribute it to the m and the 5. And that's not just a 5. We're raising a -5 to the 3rd power. So I'm going to put that -5 in parentheses. And so just remember, if the negative is already in the parentheses in this first step, it should stay in parentheses in the next step. Doesn't really make much of a difference when we're cubing, but if you were squaring or raising to the 4th, or some even exponent, it would make a difference. So we have -5 cubed and m squared cubed. And you might get to the point where you're noticing that you need to multiply your exponent straight away. Perfectly fine. Make sure that you're still remembering to distribute to every part of that term. All right, so -5 cubed, -5 times -5 times -5 gives us -125. And then we multiply our exponents and we get m to the 6. All right, and one thing I want to note here is that this power rule B, this does not apply to sums. And so what I mean by this is that if we have a plus b in parentheses squared, we can't distribute this exponent here. So you can only distribute when it's a product on the inside, or like we'll see in a second, if it's a quotient. What I usually call this rule is power of a product rule, because it's explicitly with products. With sums, it's a little bit different. We'll actually see that in this chapter, but you cannot distribute. This is not a squared plus b squared. And we'll see why that is when we start multiplying polynomials. All right, let's look at our last power rule. This one we'll call power rule C. And so power rule C, I'm not going to write out the explanation for this one, but it's the same thing as what we saw for the power rule B. If we have a quotient, so A over B, and we're raising that entire thing to the m power, we can go ahead and kind of distribute, and so we get A to the m over B to the m. So let's go ahead and look at some examples of this, and then we'll combine all of our rules together in a few examples. Number 1, we're given 5 over 2 to the 4th. So for this one, instead of taking 5 over 2 and writing it out times itself 4 times, we can distribute this exponent in. So we have 5 to the 4th over 2 to the 4th. 5 to the 4th is one of those where it's kind of on the border. It's getting kind of big, but it's not too big. Generally, if it's under 1,000, I'll multiply it out. So 5 to the 4th is going to give you 625. And 2 to the 4th gives you 16. If we could, we would still want to reduce. We can't reduce here though, but still keep that in mind, always reducing. Number 2, same thing if we have variables, so p over q in parentheses squared. We're again going to distribute this in, so we get p squared over q squared. And sometimes with these, it's kind of hard to tell when to simplify or when you should be done simplifying. And as a general rule of thumb, if there's nothing else that you can do to the expression, you're done simplifying. So since we were able to distribute here, this is considered more simplified. There's nothing else we can do to combine these two terms here. Same thing over here. So we can no longer simplify it. Let's go ahead and try one more. 1 over x in parentheses to the 10th. And again, we're going to distribute. So we get 1 to the 10th over x to the 10th. And 1 to any exponent is still 1. So we're taking 1 and just multiplying it by itself. X to the 10th, we can't simplify that because we don't know what x is. So we get 1 over x to the 10th. All right, so like I said, for our last set of examples, we're going to kind of combine all of our rules together to see some examples that use all of them. And these are just the first rules. We will have a couple more rules in the sections coming up, but we're almost done with them. So again, for these examples, we're just told to simplify. I keep writing words as I say them and just completely changing what I'm writing. Wrote exemplify. Okay, examples. Simplify, there we go. Number 1, we're given 2m in parentheses to the 5th, and then another 2m in parentheses cubed. All right, so this is one where there's, and this is true for a lot of them, there's a couple different ways to do this. So one thing you can do is you can distribute first. And a lot of the time I'll say that we want to clear parentheses first, kind of like when you simplify expressions or equations. This one, there's actually something a little bit nicer to do so that we don't have to deal with having so many terms. If you notice that you have the same base for both of these, a lot of the time they won't give you the same base. So this is kind of one of those ones that you get from time to time, but not that often. Since we have the same base, we can use our product rule. So remember, product rule, we keep our base, so keep the 2m in parentheses, add the exponents, so 5 plus 3 is 8. And now we can finish simplifying. So at this point, I'm going to distribute. So we have 2 to the 8th, m to the 8th. And 2 to the 8th, 8 is a really big exponent for a number, but if you multiply 2 times itself 8 times, you only get 256. So a lot of the time, 2's to an exponent, we'll go ahead and multiply out just because they don't get too big. So 256 m to the 8th. Number 2, got 5k cubed over 3, and this entire thing is squared. So unlike the last one, there's nothing we can use product rule with because we're not multiplying things together. And so what we want to go ahead and do for this one is clear the parentheses. So I'm going to distribute this 2 into every single part of every term inside the parentheses. So we're going to distribute to the 5 on the top, the k cubed, and the 3 on the bottom. So we're using power rule B and C, and then we'll use power rule A in a second. So I'm going to write these out. So now we have 5 squared, k cubed squared. So make sure that k cubed is in parentheses. And then on the bottom, 3 squared. And then we'll simplify what we can. So 5 squared, 5 times 5 is 25. Think about what we do here with our exponents. 3 and a 2 separated by a parenthesis, we multiply, so k to the 6th. And 3 squared is 9. Just double check to make sure that you can't reduce here, and we can't because we have 25 and 9, no common factors. All right, let's try a couple more. Number 3, 1/5 in parentheses to the 4th times 2x in parentheses squared. So with this one, we have two things being multiplied, but unlike the first one that we went through, these had the same base. These do not, so we can't use our product rule. So the first thing that we have to do here is distribute that the exponents to both of these terms here. So we'll distribute the 4 to the top and the bottom, and then we get 1 to the 4th over 5 to the 4th times, distribute this 2 into both of those, so 2 squared x squared. And then I'll simplify separately, and then we can try multiplying. So 1 to the 4th, still 1. 5 to the 4th is not too bad, it's 625. And then multiplied by 2 squared is 4. Can't simplify x squared. And these aren't the same base, but we're not talking about exponents anymore because this first one doesn't even have one. We're just multiplying two regular terms together. So just remember, if you're multiplying by a fraction, I'm going to make this 4x squared over 1, multiply straight across. So we get 1 times 4x squared is 4x squared, and 625 times 1 is 625. So make sure you're still using your old fraction rules and all of that for simplifying. Don't let the exponent rules kind of deter you from using your fraction rules. And again, 4 and 625 can't be simplified or reduced. Final one here, and this one's a little bit longer, but if you can try to do it by yourself, or at least get started by yourself, definitely recommend doing that before you watch me go through it. So in parentheses, -3xy squared, all of that cubed. So remember, if it's in parentheses now, it should stay in parentheses. And then in parentheses, x squared y to the 4th power. So think about what you can do here. We don't have the same base, so we can't use product rule. First thing we have to do is distribute. So -3 cubed, keep that -3 in parentheses, cube it, and then x cubed, and then y squared cubed, so y squared in parentheses cubed. This is all just multiplication, so I'm just going to kind of tack these terms onto the end. So now we have x squared to the 4th. If you want to kind of separate these two, you can put that multiplication there, but because it's all multiplication, you don't need this. And then finally, we have y to the 4th. Now let's see what we can do to simplify. So -3 cubed, -3 times -3 is 9, times -3 is -27. X cubed is just x cubed. Y squared cubed, we multiply, so y to the 6th. I'm going to leave off this multiplication dot. X squared to the 4th, multiply, so x to the 8th. And finally, y to the 4th. And now think of this like you're combining like terms. So if you see any common variables or coefficients that you could multiply, you want to multiply those together. -27 is the only coefficient, so I'll leave that out in front. X cubed times x to the 8th. Since we're multiplying the terms, product rule, we're going to add the exponents. Again, think of this like how many x's are we multiplying all together? We're multiplying 11 of them. And then y to the 6th times y to the 4th. Again, add those exponents and we get y to the 10th. So as long as you break these down into the little individual steps, like I said, you can go straight from this step to this step here and skip over this part. But I find this part really helpful so that you're not making little mistakes along the way. So next time we'll take a look at some integer exponents, which means positive and negative exponents. And then our other rule, which is the quotient rule.